All right, hey boys and girls, so today we're going to be going over Unit 12, Lesson 1, which is rational versus irrational numbers. If you can, if you have a cell phone or an iPad or anything like that at home, and you can download that app that we've been referencing in some of our videos, I'm just going to write it here on the side. It's Calculator X. And then it has like the number 84 after it. It's a free app and it's going to help you a lot because it looks just like the calculator that we use at school. And it's going to, again, just help for this unit, just all the buttons that you should press, things you should be looking at for when you come back to school with us, hopefully before the year is out. Okay, so if we look at the do now, it says use your calculator to write each of the following as a fraction. So if you did have your graphing calculator on you, I actually don't even have one myself at home, so that's why I downloaded this app. 0.25 was the first fraction. So, or the first decimal, I should say, that we have to turn into a fraction. So in school, we would have you type in 0.25 into your calculator, and then on the side, you would press math and then fraction. Okay, this is something that we've done so many times, so you guys know how to do that. And then you would press enter, and it would automatically make it a simplified fraction for you. All right, so that's what we're gonna do here. I'm just gonna use this app on most of the questions just to refresh you on what buttons to press, what everything does, things like that, okay? So 0.25 is really 1/4 as a fraction. Next is the square root of 25. So let me type that in. The square root of 25. It says it's just the number 5. So I could press math and try to turn it into a fraction, but I know that every whole number is over 1. So I'm just going to put 5/1 and call it a day. And then part C is the square root of 5. So I'm going to go back. Same thing, square root of 5, enter. And I can see that I have this big decimal, but that's okay because I can press math, fraction, and it'll turn it for me. I don't know if it works that time, so let's write down for this question because you can see that it's just this big decimal here and it didn't change into a fraction. So I'm just gonna write cannot be written as a fraction. All right. And this is important for today because that's the difference between a rational and an irrational number, okay? This is the goal of today's lesson. If I can write something as a fraction, that makes it rational. If I cannot turn a number into a fraction, that makes it irrational. Okay, so if we look down at the notes underneath, let's just start with going over rational numbers. It says a rational number, well, we just said a rational number can be written as a fraction. All right, I'm going to star this all around because this is going to be your go-to definition for rational. All right, this is like the full-on definition of what makes something rational. So let's just start off with rational numbers either terminate or they repeat, okay? It's a repeating decimal, I should say. Okay. So I don't know if you guys are too young for this, but there's a movie called The Terminator, and I know that a lot of math teachers like to reference that when we go over these words. So the Terminator in the movie, he's just ending things, all right? So if you're looking for something that's terminating, it's something that is ending. All right, so a terminating decimal ends. So that's the first choice that we have when it comes to a rational number. If something is rational, it's because it's terminating. It's just like this decimal here, 1.557, it stops at 7. It's ending. So this would be a rational number. Or I have a second situation. It could be a number that has a repeating decimal. So it's the same thing. If I look at this example underneath, well, 1.3, 3 is repeating this whole time. So since 3 is repeating, I know that this is also considered a rational number. It either has to end or it has to repeat. All right, so both of these would be rational. So if I look at the example underneath, it says circle all of the rational numbers. So again, I'm just going to go ahead and highlight that. I'm looking for only rational numbers. And if you remember, a rational number can be turned into a fraction. All right, so if we look at the first choice here, I know that every number is over 1, okay? Just like in the do now from before. So I know that I can just take the whole number 5 and put it over 1. Now it's a fraction. If it's a fraction, it's rational. Number 2, 1/3, it is a fraction, so it's rational. I'm gonna circle that. Number 3 is a little bit different, so let me grab my calculator for that. All right, so we have the square root of 3. So let me just type that in, the square root of 3, enter, and I have that big decimal, but let me just check. Can it be turned into a fraction? And it can't. So I know that that would not be a rational number. So just for practice, I just want you guys to add this to your notes. The square root of 3 is 1.73205 ... Okay, because it's going on forever. I can see that this decimal is not terminating. It's not ending. And I can also see that it's not repeating. None of these numbers repeat. So since both of these don't occur, can't be turned into a fraction, right? This is not a rational number. This bar is a repeating decimal bar. So this is definitely rational because it's telling me I have the pattern 318 forever. All right. Next, the square root of 36. I could type that in, but I know a lot of you guys know it off the top of your head. It's just the number 6. So again, any whole number can be written over 1. So since it can be written as a fraction, this is rational as well. If I look here, so this I can't really type into my calculator. I have to know these definitions. So I'm going to check, is it ending? No, because I have those decimals. And then is it repeating? I don't see any numbers that repeat here. So this would not be a rational answer. Next, 0.1. So 0.1, I could try to type that in my calculator, but if I just jump here to my notes, it's a terminating number. It's ending. 0.1, it's done. So this is definitely going to be a rational number. And then last but not least, 0.5858, right? It's going on and on forever. So is it terminating? It's not ending, but is it repeating? Yes, it's absolutely repeating, so that makes it a rational decimal. All right, next, let's go over irrational. So irrational is the exact opposite of rational. All right, so right at the top here, it tells you that an irrational number cannot be written as a fraction. All right, so let's just star that. Let's box this, and that's going to be your go-to definition for irrational. Okay, so an irrational number, like we had just said, is something that does not repeat and it does not terminate. It's the opposite of rational. So if I have a non-terminating decimal, let me just add that on here. It means that it has a decimal that does not end. Okay, and let's highlight that vocab word here. Underneath, we have an example. So here's my numbers. So this would be something that is non-terminating. It doesn't end. So there's no repeating decimal. The dots tell me it goes on forever. There's no pattern. Okay. And then underneath, and it goes on forever. Okay. Non-repeating decimals would be my second go-to. Let's highlight that if you guys have one. Okay, so a non-repeating decimal means that it doesn't repeat. It does not show a pattern. All right, and then we have this example right here. So I can see that this is not ending because of the dots, but it's also not repeating because it looks like the 3s go on forever, but they don't, because then we have 5, 6, 4, 3, it's changing. All right, so this would be not repeating. So now if we look at example 2, I want to circle all of the irrational numbers. Let me just highlight that again. And you guys can always box these if you don't have a highlighter, that's fine. And now let's quickly go over them. All right, so if I look here, is this irrational? And my answer would be no, this is not irrational. Do I see that this is ending? It is ending. I need something that doesn't end, so this would be rational. I'm gonna go to the next one, the square root of 13. So let's try typing that into my calculator because I don't know what that would be. So let's go here. And then again, I'm just going to type in the square root of 13. And I get that big decimal. So now I'm going to try to turn it into a fraction. And it didn't work. All right, so since it cannot be written as a fraction, cannot be turned into a fraction, I know that this would be an irrational number. This is a fraction. I'm looking for something that's not a fraction. So this is rational. Next, 4.23. I'm looking for something that does not end, and this does end. So that's rational. I'm looking for something that does not repeat, and that's literally the repeating bar symbol. So that's rational. And then last but not least, I'm looking for something that does not end. So I see some dots, looks like it goes on forever. And I'm looking for something that does not repeat. None of these numbers repeat, so this is definitely an irrational number. All right. So now we're going to take what we just learned and apply it to these rules here. So if we look at the top, it says the sum and product of rational and irrational numbers. So I know that sum is a keyword. Sum tells me to add. And I know that product is a keyword. Product tells me to multiply. So I'm just going to fill that in from the start. All right. I want to look at the first definition here. So it says that the sum of two rational numbers. So when I add two rational numbers, it's saying that my answer should be rational. All right. And we're just going to test that to see if it's true or not. Okay. So if I look at the first example here, I know that these are both rational numbers because they're telling me two r's, give me an r. All right. So if I take the first rational number and add it to the second rational number, what do I get? All right, you can go through and type all of these in on that calculator app if you have it at home. And if you don't, just kind of follow along with me for right now. But when you type this in, you should be getting 2.25. Okay, this is a rational number because it's a terminating decimal. It does end, doesn't look crazy. And I could turn this into a fraction if I wanted. All right, so far this first one is true. Now let's try the next one, product. So the product tells me that when I multiply, so if I multiply two rational numbers, I should be getting another rational answer. All right, so I'm just going to fill that in. A rational number times another rational number gets me what? Well, if I did half of the square root of 16 in the calculator, I should be getting the number 2. And 2 is definitely a rational answer because it's a whole number. It's terminating, right, which means it's ending, and I can put it over 1, so it can be written as a fraction. So it looks like these rational choices are working out. Now I'm going to just jump down to the bottom, and I want to look at my irrational choices. So let's go back and highlight sum. So again, I know that the sum of a rational and an irrational number should be irrational. Okay, so let's give that a try and type it in our calculator and see what happens. So I know the first number is rational and the second one is irrational. Okay, when I type those in, I get the decimal 3.414213 ... All right, it goes on forever. This is definitely irrational because it goes on forever and nothing is repeating. All right, so far this is true. And then if we try the second choice, which is the product, so it's telling me that if I multiply a rational and an irrational number, again, my answer is irrational. So if I were to type that in my calculator and try it out, so if I have a rational number times an irrational number, well, what's my answer going to be? Well, when you type it in the calculator, you get 8.944271... ... So it goes on forever and it doesn't repeat. Okay, so that is an irrational answer, so this is true as well. Okay, I'm intentionally going over the top and the bottom first because these rules are really important for you to memorize. If you have index cards at home, I would try to make some. If you have the Quizlet app, I would try to make a Quizlet on this. You can always try to look one up, but this is important. And again, I'm going over them in this order, so maybe you can see the pattern that I'm seeing. So anytime I'm just using R, my answer was R. Again, anytime I'm using R, my answer was R. All right. So whether I'm multiplying or adding with rational numbers, my answer is rational. All right. So hopefully this is an easier one for you to memorize. And then the bottom, I don't want to say it's easy to memorize because it definitely could be tricky, but it's very similar to the top. If I mix R and I, the answer is I. And again, if I mix R and I, the answer is I. So just think about when you're in an argument with someone and you're being the rational, calm, cool, collected person, and you're fighting with somebody who's being irrational, totally crazy, don't make sense. Who usually wins in that argument? Definitely the irrational person, because you can't fight with crazy. You're never going to win. All right. So if you have R and I is always going to win. Okay. Just like these choices at the bottom. So now if we go over the ones in the middle, these are the most challenging because the top has one answer. The bottom has one answer. These guys in the middle have two answers. All right. And you'll see that in a minute. So if we look here, it's saying that the sum, so when I add two irrational numbers, sometimes my answer is rational, sometimes it's not, okay? So I'm gonna just show you that in this work on the side, okay? So I know that these are both irrational numbers, and again, I know these are both irrational numbers, okay? And let's see what happens when I add them together. So if I were to type in 4 rad 5 plus 3 rad 2 in my calculator, you get 13.1869 ... okay? It goes on forever and it doesn't repeat. So this is an irrational answer. But these are both irrational. And when I add these together, I type it in my calculator exactly as I see it. I got the number 2. And 2 is definitely a rational answer. Okay, so that's why it says sometimes. Sometimes it's I, sometimes it's R. Okay, it depends on the situation, but you can always type it in the calculator and just check. All right, and then underneath, same thing. Now we're going over product. So I want to say that the product, so when I multiply two irrational numbers, again, sometimes it's rational and sometimes it's not. So again, I know both of these are irrational, and I know both of these guys are irrational. But when I multiply them together, that's the trick. I want to see what that answer looks like. So when I multiply the square root of 5 and the square root of 2, I get 3.16227, right, ... It goes on forever, and it doesn't repeat. So this is irrational. When I multiply the square root of 8 and the square root of 2, I got the number 4. And 4 is definitely rational, okay? I can put it over 1. I can turn it into a fraction. It's ending, it's terminating, right? It's got everything I need for rational. So again, that's why sometimes it's rational, sometimes it's not, all right? So just keep that in the back of your mind. So now if we go to the next page, we're just going to apply everything we just learned. Okay, so when you have a question that looks like 3 or 5 and there's numbers in the question, you don't need to have this table on the side that we just went over memorized, because you can just use the calculator to check and see what the answer is going to be. So it's giving you all these variables and it's telling you what all the variables equal. It says which expression is going to represent a rational number. Okay, so again, I know that a rational number can be written as a fraction. That's our go-to definition. So I'm going to box this and I'm going to write that. Can be written as a fraction. That's my goal right now. That's what I'm looking for. So I'm just going to start off by writing out all of my choices and kind of going from there. So if I look at the first one, it's L plus M. So I'm just going to write it out. L is rad 2 plus M, which is 3 rad 3. All right, choice 2 is M, which is 3 rad 3, plus N, which is rad 16. All right, and I'm going to do the same thing for 3 and 4. So we have N plus P, and then we have P plus L. All right. Just for this question, I'm going to go back and I'm just going to show you again on the calculator how you can easily get these answers without memorizing this table. All right, because they're giving us numbers to work with. So if I look at choice 1, it says that I want to take the square root of 2, and don't forget, just like on our calculator at school, you have to arrow out. So the square root of 2 plus 3 rad 3. Okay, if I press enter, I get that big decimal. I'm looking for something that can be written as a fraction. And this can't be written as a fraction. I tried to turn it over, it didn't work. So I know 1 is not the answer I'm looking for. So now I'm going to try 2. So let me go back and clear this out. So now we have 3 rad 3. Don't forget to arrow out, plus the square root, right, or rad 16. Again, I get that big decimal. But let me check, can I write it as a fraction? Again, I can't, so that's irrational. I'm looking for something that's rational. It's not 2. So now let's try choice 3, which is the square root of 16. Don't forget to arrow out, plus the square root of 9. And I get the number 7. Okay, well, I know that 7 can be written as a fraction. I can put that over 1. Any whole number can be put over 1. So this is definitely a rational answer. I know 3 is my choice. But if this was a real test or quiz, you guys should always be checking everything. So I'm just going to go over choice 4 just to make sure we didn't make any mistakes. So if I have the square root of 9, arrow out, plus the square root of 2, I get that big decimal. Can I turn it into a fraction? No. So I know that choice 3 was definitely the answer. Okay. I'm going to go to number 4. So it says, which statement is not always true? So I'm just going to highlight the word not because I'm looking for what's not going to always happen. All right. So if I read the first choice, it says the product, and I'm just going to box that because it's a key word. So the product, that means when I multiply 2 irrational numbers, it's saying that my answer is irrational. Well, let me look for when I'm multiplying 2 i's. So I'm multiplying 2 i's right here. And it's telling me on my table that the answer is I or R. Sometimes it's irrational or sometimes it's rational. So what's not always going to be true? It's choice 1. Because sometimes it's irrational, sometimes it's rational. It's not always going to be this one answer. All right, so it just so happens choice 1 was the answer for 4. And then number 5, same thing as number 3. So at this point, if you want to try to pause the video and try 5 on your own, I would encourage you to do that. If you want to keep on watching, that's fine too. Whatever is going to help you the most. All right, so if I look at example 5, it says given, and I have all these variables with all of those numbers. What's going to give me a rational number? And again, I know that when I see the word rational, I should be thinking it can be written as a fraction. Please write this with me on your notes. This is so important. All right. So now if we look down at our choices, it's just like number 3. If I add A and B, let's see what happens. So A is the square root of 16. B is the square root of 31. All right, so I'm just going to write all of these out really quick. So we have C plus A. I have A plus D. And then we have C plus D. And then I would just grab my calculator and start typing these in and just seeing what happens. So again, I want something that can be written as a fraction. So if I look at the first choice, it's the square root of 16, arrow out, plus the square root of 31. Enter. Let me try to turn it into a fraction, and it can't be written as a fraction, so I know that choice 1 is not the answer. All right, clear my calculator. Let's try choice 2. Square root of 13, arrow out, plus the square root of 16. Let me try to turn it into a fraction, and that didn't work either. Okay, so it's not going to be choice 2. All right. So now if I try choice 3, same thing. So I'm going to do the square root of 16. Square root. Oh no, what's happening? Okay. Square root of 16, arrow out, plus the square root of 100. And I'm getting the whole number 14. All right, and that's what I was really looking for, something that could be written as a fraction, because I know that every whole number can be put over 1. All right, so I know my answer has to be choice 3. And then again, if you try choice 4 and you type this in, it can't be turned into a fraction. And then it says explain your reasoning for choosing your answer. So how did I know for sure that this was a rational number? So I'm just going to start off by kind of restating the question. So it's rational. I know that it is because it can be written, you got it, as a fraction. And that's literally all you have to say. So this whole time you're either deciding if it can be written as a fraction or if it can't. And again, you're going to check that each and every time on your calculator by pressing the math button. And then it's the first choice, guys. It's fraction. You're just going to check it, type it, and see what happens, okay? So now let's go to the next page for example 6. So if we look at example 6, it says, Mrs. Fox asked her class, is the sum of 4.2 and rad 2 rational or irrational? So I'm going to just stop for 2 seconds and kind of identify what's important here. So again, if I look here, I can see that the sum is an important vocab word. Sum tells me to add. And then we have our two numbers, 4.2 and the square root of 2. So she's asking if it's rational, which is a vocab word, or if it's irrational, which is an important vocab word. Patrick answered and he said that it's irrational. So Patrick said it's irrational. State whether Patrick is correct or incorrect. This is where they try to get you on those tests, quizzes, the regents, right? Things like that. You guys are like, it's rational because blah, blah, blah. Or you'll say it's irrational because blah, blah, blah. Meanwhile, the question asked, is Patrick correct or incorrect? In order for you to get that first point, you have to literally write Patrick is, and then what is he? Was he right or was he wrong? So I'm going to start off by just writing that so I don't forget. That's what I have to do to answer the question. So I'm going to say Patrick is, and right now I don't know if he's right or wrong. I'm going to try this out in my calculator to check and see if he's right or wrong. So let me just open up that app one more time. And I'm just going to type it in. So I'm going to add 4.2 and the square root of 2, right? Rad 2. Okay, I get my decimal. And now I'm going to check math. Fraction. Can it be turned into a fraction? And it cannot. So on the side, it says Patrick is, well, it was irrational, and he said it was irrational. So Patrick is correct. Because, now, why is it irrational? Because it cannot be written as a fraction. That's what we just tried out on our calculator. That's how you know if you're right or wrong, or if it's rational or irrational. You're just checking if it's a fraction or if it's not. All right. And then if we look at example 7, last but not least, it says, which is an irrational number? So I'm going to go ahead and just highlight. Again, now it's asking us what's irrational. And just as a refresher, if it's irrational, that means that it, just like we already wrote, cannot be written as a fraction. So if we look at choice 1, I know I've said this a few times now, any whole number can be put over 1. So I can write 0 over 1. Now it is a fraction. It's not what I want. Let me try choice 2 because pi is a big number. So let's just see if I can find that on this app. I know it must be here somewhere. I found it. Okay. Whoop. So here's the pi button. So I'm just going to press enter. So I get that decimal. So now I'm going to check, can it be written as a fraction? No, it can't be. And that's what I'm looking for. What can't be written as a fraction? Well, pi, that symbol, it cannot be written as a fraction. So I know it's going to be choice 2. If I look at choice 3, that is a fraction. And if I look at choice 4, I know you guys know the square root of 9 is 3. But just like choice 1, any number can be put over 1. So I can put 3 over 1. And now it is a fraction. So that didn't work. It's definitely choice 2. And then it says explain your reasoning for choosing that answer. So again, I know it's rational. I'm kidding. It's irrational because it cannot be written as a fraction. All right, please take time, boys and girls, when you get a chance. You got to have this table memorized, especially if we go back to school, just so you're prepared and ready to go. If you have questions, please email us. You're doing such a great job turning in work. Make sure that you're clicking Algebra 1 and then assignments every day. You should be checking for a new lesson every day, all right? So keep it going. You're doing such a great job. We'll talk to you soon.